Hello students, welcome to Distinction Learning Platform, and on this platform you'll find revisions, tests, explanation to difficult topics, a lot of stuff. So before we begin our lessons, make sure that you subscribe so that you can be updated with our upcoming videos. To make the story short, let us begin. In this video, we're talking about extraction of metals, particularly under extraction of iron. Okay, although there are other extraction of metal like extraction of copper, extraction of zinc, we'll talk about that. Extraction of aluminium, we'll talk about that. Okay, now before we proceed to extraction of iron, we need to understand about the extraction of metals just a little bit. Okay, so if you talk about extraction of metals, so let us talk about it here. So if you talk about the extraction of metals, okay, of all metals, it's going to depend on what we call reactivity series, okay, on how metals are going to react with one another. So it's going to depend on reactivity series, okay. So it's going to depend on that, okay. There are what we call most reactive metals and moderate reactive metals, as well as the lowest reactive metals. So it's going to depend on that. So if you talk about the most reactive metals, I'm just going to pick one example, okay, but we'll talk about reactivity series in other videos, okay. So how can you extract a most reactive metal? So most reactive metal, how do you extract them? So there is a method that we use to extract the most reactive metals. We use what we call electrolysis, okay? So we use this method which we call electrolysis, okay? So again, if you want to extract the most reactive metal, what method are you supposed to use? Electrolysis, where you're going to use electricity in order for you to obtain that metal from that mix of minerals, okay? You need to understand about that. Now, what is that good example of that metal which is the most reactive? So we can just pick the most reactive metals. You can just pick 2 or 3. So you can talk about sodium. Sodium is most reactive, okay? Also, if you look at potassium, is most reactive. If you talk about calcium, if you talk about also aluminium, so these metals that I've written here, potassium, sodium, calcium, and aluminium, they are most reactive. If you want to obtain these metals from their ore, basically you are going to use what we call electrolysis. Why? Because they are most reactive, okay? Now, if you talk about now the moderate reactive metals, they are going to have another method. So moderate reactive metals are going to have another method. Apart from electrolysis, there is also another method, okay? What is that method that we know for you to to extract a moderate reactive metal, okay? I'll also give good examples of those moderate reactive metals. So what is that? So we call it what? Reduction method, okay? So reduction method, basically you're going to be using what? A reducing agent, okay? So mostly we use that reducing agents as what? Carbon monoxide, okay, or just carbon itself. So, but basically we just use what? Carbon monoxide here, okay? It's the one that we're going to use under extraction of iron, okay? So now, what are the good example of metals that uses what? The reduction method. We use what we call, we have this metal, the same metal that we'll be talking about here, which is iron. Iron, we're going to use what we call reduction method. Why? Because it's not that most reactive, it is what is moderate reactive according to the reactivity series. Apart from that, what other metals can you use reduction method? Like metals like zinc, okay? Zinc can also be extracted using reduction method, okay? Lead, all those metals can be used, you can use reduction method, okay? So that is just an overview of on how you can extract metals. It will depend on what reactivity series. If the metal is most reactive, what are you going to use? You're going to use what? Electrolysis. Basically, that is, you are using electricity in order for you to extract that metal. Then what is the other method, which we call reduction method? Why are you using reduction method? It is because the metal that you are extracting is what? Moderate reactive, okay? Like zinc, like what? Iron and zinc, like that, okay? Or there are other metals that are important. But if you talk about metals like gold, talk about like platinum, how can you extract such metals? So those metals, they are what? Unreactive, okay? They are not reactive. So basically, you're going to find them just native in their what form. They're not going to be found in form of what there, or you don't need to use any method for that because they naturally occur like that. So metals like gold, metals like platinum, metals like silver, those you don't need to what? Extract, because those are the lowest reactive metals, and basically you are going to find them naturally occurring, okay? They are not going to be found in mixtures. Okay, so since we know this, then let's go to extraction of what? Iron, okay? Iron, how do you extract iron? So we know that we extract iron using what? We now know using what? Reduction method. Why are we saying reduction method? Because iron is a moderate reactive what? Metal. Basically, you're going to use a reducing agent that we'll talk about, okay? Now, this iron, this same iron, where can you find it on the periodic table? Okay, so this iron, where you can find it on the periodic table, you can find it in the what? Transition what? Metal block. So where there's a block on the periodic table which is on the middle, where you can find transition metals. If you say transition metals, these are the metals that transit. Basically, they change their what? Valence numbers. Okay, they transit. If you look at iron, there is what we call iron 2 plus, iron 3 plus. As you can see, there are two different states of what? Iron. So no wonder it's under transition metal, because it changes from one state to another state. Okay, so you need to take note of that. Okay, so we know about that. Now let's talk about something. Now, where can you find iron? Quite alright, we know that iron, you can extract it using the reduction method, but where can you find it? Okay, you can find it from what we call ore. This one, okay. You find question talking about ore, then they ask you to say, what is this ore about? Okay, what is this? Okay, what's the definition, proper definition of this? So if you look at ore, basically it is what? The mix of minerals and the impurities. So mix of what? So it is a mixture. Only in the timeline. Mixture of what? Minerals and impurities. So whenever they ask you to define an ore, you can just say it's a mix of what? Minerals and what? Impurities. Okay. Now, what is the ore for iron? So what is the ore for iron? What do we call the ore for iron? What do we call that? We call it what? Hematite. You need to know about that. So the ore for iron is what we call hematite. It's the most common what? Ore for iron. Remember that what is ore? It's a mix of what? Minerals and impurities. Okay. So hematite is the ore for what? Iron. So hematite. Okay. This one. So hematite is the ore for iron, but there are also other ore for iron. Apart from hematite, there is also another one which we call magnetite. Okay. We call it what? What do we call this? Another ore for iron, we call it what? Magnetite. This one. Okay. So there are two important ore for iron. The first one is hematite. The second one is what? Magnetite. Okay. Now, you know, under chemistry, we don't just write words, we write something which is in form of what? Chemical formula. So if whenever they ask you what is the chemical formula for hematite, because it is very, very important, it's the one that we'll be talking about under chemical equation. Okay. So what is the correct formula for what? Hematite? It is what? Fe. So Fe, that is for iron. The chemical symbol for iron is Fe. Then you're going to put 2 here and 3 here. Okay, that is the correct what? Formula for what? Hematite. Now, the question that you can ask is that how did I form this hematite formula? Okay, basically let's go to the basics of what? Chemistry. So if we know that in hematite there is what? iron, okay, and we know that in high method there is what? Oxygen. So let's try to form that formula that I've written on the board. Okay, if you look at iron here, we're going to put a number here, but since iron is under what? Transition block, it is under transition method. Why can you get the valence number? Okay, why can you get that? So basically we're going to say under transition methods are going to have particular valences or specific valence according to their state. So this hematite is going to have iron 3. Okay, so we are going to have the valence number for iron is what? 3. So iron 3, that is for hematite. So here the valence number for iron is 3. Why? Because that is iron 3, the one that can be found in what? Hematite. What about oxygen? Oxygen is in periodic is in group what? Is in group 6. So what we do is 1 to 4. Okay, so for you to find the valence number for a certain element in a particular group, we follow this rule. From 1 to 4, the valence number is a group number. So let's pick 1. If you say, if I get calcium, we know that calcium is in group what? It is in group 2. Since it is in group 2, and the rule states that any element from group 1 to group 4, then the valence number is a group number. If calcium is in group 2, then the valence number of calcium will be what? 2. Okay, so apart from that, what about this one? 6 to, starting from 5, since how many groups are there on the periodic table? They're about what? 8. Okay, so here starting from 5 now, the rule changes. Now starting from group 5 to 8, the rule changes. So now how can you get the valence number for an element that is in group 5 going up to group 8? How do you do that? You get 8. So this is the formula that you need to be what? Getting or doing. So you get 8 minus what? The group number. So let's just say Gn, which is the group number. Okay, so you get what? 8 minus group number. Element for those elements in group 5 up to what? Group 8. Now if you look at oxygen, if you go to the periodic table, you find oxygen, it is in group what? 6. So how can you find the valence number of oxygen? You're going to say 8 minus, since oxygen is in group 6, we're going to use that formula. You're going to say 8 minus what? 6 for us to get what? 2. Okay, so oxygen is in what? Group 2. So I'm going to put the valence number there. The valence number for oxygen is what? 2, because I've subtracted 6 from what? 8, then getting 2 there. So it's the one that I'm going to put here. The next procedure is what? You're going to cross multiply here as usual. So you're going to say 2 times F, always start with a metal. So you're going to say F2. Okay, 3 times oxygen, then it will be what? 3 oxygen. As you can see, it's the one that I've written here. This is how they got this formula. Okay, so this is hematite. Okay, or the other term that we can use, or the chemical name for this one, you're going to say iron 3 oxide. So this is what we call iron 3 oxide. Okay, so now you're also wondering what is the formula for magnetite? So magnetite formula is something unusual. So you're going to say magnetite formula is this one, F3, okay, F3, then O2. So that is the formula of what? Magnetite. So these are the important O for iron when it comes to extraction of iron. Okay, so now let's proceed. Yeah, so as you can see this one now, this is a certain diagram where iron is going to be extracted from its ore, like what? Hematite or magnetite. Okay, now this, what do we call this diagram here? Maybe you are going to be assessed on this one. You need to know this diagram, the name of this diagram. What is the name of this diagram? We call it what? Blast furnace. Okay, we call it what? Blast. Okay, we call it blast furnace or furnace. Okay, whatever you're going to pronounce it. Okay, so this is what we call a blast furnace. Okay, so this blast furnace now is a basically it is the diagram, or basically it is what it is a structure that we are going to use in order to what? Extract iron from its ore. Okay, it's this diagram which is very, very important now. Okay, now let's talk about this same blast furnace. As you can see, blast furnace is going to have these numbers inside here. Okay, these are what we call what? These are what? Temperature figures, okay? As you can see, starting from 200 degrees Celsius up to what? 2000 degrees Celsius. As you can see, as you're going down to down the blast furnace, basically the temperature is going to be what? Increasing. So what is that indicating? It is telling you to say on the top of the blast furnace it is cold, then below the blast furnace it is what? Hotter. You need to understand about that, okay? Now, the important thing that you need to understand about that is that what are the things that are going to put into the what? Blast furnace, okay? There are important things that you're going to put inside the blast furnace, and how many are they? They're about what? 3 important things that are added in the blast furnace. So we're saying how many? So let's start with the first one. Let's use blue. So the first one that is going to be added into the blast furnace is what? Iron. Now iron is not particularly iron, it is in form of what? Ore. So the first important thing that we're going to put here is what? Ore for what? Iron, okay? What do we call that ore for iron? Hematite. So what you need to specify here, because there are a lot of ores that you need to know, but here we need to specify, since we are talking about iron extraction, you're going to say hematite. Don't get magnetite. Magnetite is not a common ore for iron, but we use what? Hematite. So here, let's just put capital letter H. So if you're asked to say what are the 3 important things that are fed into the blast furnace, you say hematite, and the second one here is this one. Okay, you need to take note of this. What is the second one that's going to be added in the blast furnace apart from hematite? Okay, we call it what? Coke. Okay, we call it coke. Sometimes it is referred to what? Carbon, okay? Coke or carbon is another important thing that is added into the what? Blast furnace. Very, very important, okay? What else apart from that? Another one, let's use black, okay? Another one now, another one, it is what we call limestone, okay? Limestone, okay? That is another important thing or substance that is fed in the what? Blast furnace. Limestone, hematite, and coke. These are the 3 important substances that are added in the what? Blast furnace. Very, very important thing. Remember that now, if you talk about limestone, it has also another name, okay? If you heard about calcium carbonate, basically calcium carbonate, that is the chemical name for limestone, okay? So it has the same name, limestone or calcium carbonate. Okay. So now, since we know 3 important things that are added in the blast furnace, what is the other important thing? Other important thing is what now? Talking about the chemical equations that are involved in the blast furnace. Very important, because you're going to be assessed on that, okay? You need to know. That's what a problem is, but you need to follow step by step so that you can't forget about the chemical equation that happens in the what? Blast furnace, okay? So let us start with the first one. So what is the first chemical equation that's going to be there in the blast furnace? Now let's try to think about something important, okay? You've seen this hot air, okay? Sometimes they call them hot air gases, okay, or hot gases like that, okay? Whatever the name that you are going to find, but basically this is hot air that is being fed in the water blast furnace. Hot air, particularly if you are talking about chemistry, you are talking about the oxygen, okay? If you just see a question talking about, let me just give you an example. If you say, they say sodium reacted in air, basically they're talking about sodium reacted with oxygen, okay? So just from that, hot air, we are talking about hot oxygen. Hot oxygen is being fed in the water blast furnace like that, okay? And I'll tell you why this hot air is being fed in the blast furnace, okay? Is to do something that we're going to talk about here, okay? Hot air, we're talking about oxygen that is going inside the blast furnace. Let us write it. Let us write it in form of what? So let's say that is oxygen that is being fed in the blast furnace like that, okay? Now this oxygen, as you can see, is going to receive something that is important. What are we feeding here? Coke. But what's the chemical name for coke? Carbon. So carbon is going inside and it's going to find what? Oxygen. If it is finding oxygen, basically there will be what? A chemical reaction that's going to happen. So what we are particularly saying here is what? Carbon. Let us use blue. Carbon is going to react with what? oxygen. Why? Because oxygen is already there. So make sure that you need to put a 2 here whenever you're writing chemical equation for a gas. Okay, if you are writing a gas in a chemical equation, what are you supposed to write? You need to put a 2 here. Okay? Why are we putting a 2 here? Because all gases, they exist as what? Diatomic molecules. Okay, diatomic molecules, what does it mean? It means that the same compound, okay, the same compound, it has what? 2 atoms that are chemically combined. Okay, so like as you can see, oxygen is having what? How many atoms that are there? There are 2 atoms of oxygen. So if 2, it means what? Di means 2 diatomic molecules. Okay, so even if I was to ask you to say, how can you write nitrogen in what? Let's say in any chemical equation, how do you represent nitrogen? Since this nitrogen is a gas, what are you going to do? You're going to put a 2 there. Okay, so you need to know about that. Now this carbon and oxygen, they are reacting together. What do you think will be the product? The product will be carbon dioxide. Okay, what will be the product here? It will be carbon dioxide. We all know the formula for carbon dioxide. It is CO2, like that. Okay, that is carbon dioxide. So that's the first step. Okay, so basically this coke that is coming in and it's going to find oxygen. Basically, if this is oxygen that is there, okay, if that is oxygen that is there, then it's going to produce what we call carbon dioxide. So let us try to represent what I'm saying here so that you can visualize what I'm saying here. So we're saying this carbon that is coming in and it is finding what? Oxygen to form what? Carbon dioxide, like that. Okay, inside here. Okay, this is the carbon dioxide that we're having. Now this carbon dioxide that we are producing here, particularly to be there, okay, now it's going to receive more coke, okay, because we are still feeding more coke in the what? In the blast furnace. So what are you supposed to have the next equation? So the next equation, what you need to do is you need to get what? Carbon dioxide here. You need to get what? Carbon dioxide. So you say, okay, this carbon dioxide that is being produced by the first equation is going to react with what? More coke. Okay, more coke, basically more carbon. Why reacting with more carbon? Because we are still putting carbon here in the what? Blast furnace. So the carbon dioxide is being produced. Now it's going to react with more coke that is coming in the blast furnace to produce what? Which is most important. Okay, what is that? It is producing what we call, since there is more carbon compared to oxygen, then you are going to produce what we call carbon monoxide. Okay, carbon monoxide, very important. Okay, now there was a question that I encountered. Okay, you're going to find the question to say, in the blast furnace, how can you produce what? Carbon monoxide, or the reducing agent. How do you produce that? So particularly they are asking to say, what are the 2 important equations that are involved to produce what? This carbon monoxide, because there is a question that can come here, so you need to pay attention on that. So how do you produce carbon monoxide? How can you answer such a question? You say, okay, firstly, carbon and oxygen, they are going to react to form what? Carbon dioxide. Okay, and this type of chemical equation is what we call combustion. Okay, so you're saying carbon and oxygen, they are going to chemically combine in combustion reaction to produce what? Carbon dioxide. And this same carbon dioxide that is being produced is going to react with more coke that is being fed in the blast furnace to produce what? Carbon monoxide. This is carbon monoxide. Okay, and this carbon monoxide is what we call what? A reducing agent. So this one is what we call reducing agent. Okay, it is called the reducing agent. I'll tell you why it is called a reducing agent. Okay, now since we have this carbon monoxide, because our main objective in this chemical equation is to produce what? The reducing agent. Okay, now what is the number 3 chemical reaction? So number 3 chemical reaction, we're going to get this carbon monoxide to use it, okay, to make sure that we extract iron. Now what are you going to get here? On number 3 chemical equation, we're going to get what? Hematite. Okay, we're going to get hematite, but don't get the word, take the what? Chemical formula for hematite. What is the chemical formula for hematite? We're going to respect the hematite in form of the what? Using the red marker. Okay, so I'm going to say hematite. What is the chemical formula for hematite? Fe. Okay, then we're going to say this is 2, which is coming from oxygen, then oxygen, then here there will be what, 3, which is coming from iron. Okay, then plus, what are we getting now? We need to get this product, okay, so that it can help to reduce this ion from its own. So this is hematite, then it's going to get what? This carbon monoxide. Okay, so as you can see, the product is helping us to form what? The other reaction. Okay, all the product are very important because they help you to form another what? Reaction. So make sure that you take note of that. Okay, now what are we getting here? So this carbon monoxide is very important because it will make sure that it's going to reduce what? Ion. This hematite is going to make sure that the ion is what? Left alone, like that. Okay, so this ion is going to be what? Left alone. Let us use something important. Okay, let us use E. Okay, so this ion is going to be left alone. Then we're going to have what? We're going to have this carbon is going to react with what? Oxygen to form what? Carbon dioxide. Okay, carbon dioxide, like that. Okay, so this is the most important equation. Okay, this one. So as you can see, this hematite is being reduced. Okay, it's being reduced by what? Carbon monoxide to produce ion and what? Carbon dioxide. Okay, so if you look at the state symbols, so what could be the state symbols for this important chemical equation? So the state symbol for iron hematite, because this is the O, it will be in form of what? Solid. Carbon monoxide, that is a gas. Okay, and this is a metal. We are going to say this is what? Solid. And this is what? A gas. We are going to say that is what? A gas. G. Now, next, we are not done with the chemical equations. Okay, we're not done. We go to number 4. Okay, number 4 now. So here we're not going to use now anything because we have the product that we need. Now we're going to start afresh because we added something as well here, limestone. We've used ore, which is hematite and coke, but we need to also look at the limestone. Remember that limestone was what? Limestone, we said it was what? Calcium carbonate. Okay, that is a chemical name. So we're saying we're not going to put limestone here, we're going to put what? Calcium carbonate here, like that. Okay, calcium carbonate. Again, if you're wondering how I'm writing this calcium carbonate, we can come here. So this is calcium and it is reacting with what? Carbonate, like that. Okay, so calcium is reacting with carbonate. Then how do you form the chemical formula? Remember that calcium is in group what? 2. Remember that 1, 2, 4, the group number is the valence number. That's what we said. So I'm going to say calcium is 2. Since it's in group 2, then it's going to have the valence number of what? 2. Now the problem is on the carbonate. Carbonate is what? A radical. Okay, so radicals are what? So there was a question that they asked to say define a radical. Okay, so what are radicals? So radicals, these are also compound, but basically they are unstable compound and they like to what? React. So you say radicals are unstable compound that are what? That like to what? React with other what? Other elements or atoms. Okay, so they are very reactive and they are what? Unstable. Okay, so now radicals are going to have their specific what? Valences. So we need to just know them because there is no formula for you to find what? The valence number for radicals. So they are just they are constant. Like for carbonate, it is well known. It's going to have 2. Okay, hydroxide, if you look at hydroxide, it's like that. The valence number for hydroxide is what? 1. Okay, it is 1. Sulfate, as you can see, it is 2, like that. Okay, so all those are what we call radicals. They are going to have what? Their constant valence number. You need to look on that. Okay, so if you look at these 2, as you can see, 2 there can go, 2 there can go, because 2 can go into 2. Okay, so you need to reduce those numbers, then you cross multiply. You always start with a method from this side. 1 times calcium, it is calcium. 1 times carbonate, it is what? Carbonate, like that. Okay, so this is now the calcium carbonate that I just wrote here. Okay, then this calcium carbonate, something is going to happen here. Okay, something is important is going to happen. This calcium carbonate, as you can see, now it's not going to react with anything because that's alone. Now the moment it enters here, remember that there are hot air that is going there. inside this blast furnace is very hot, making sure that this calcium carbonate breaks. Okay, so this calcium carbonate is going to break into two important compounds. Yes. Okay, so it's going to break. Then what are you going to form here? If this calcium breaks, I'm going to form what we call calcium oxide. Okay, plus what? Then carbon dioxide. Plus what? Carbon dioxide. As you can see, so if calcium carbonate breaks, you're going to form calcium oxide plus what? Carbon dioxide. This carbon dioxide, as you can see, it can be used in this what? Chemical equation up to the formation of what? Iron. So this one it can be used in other what? Chemical reactions there. But we are only interested in what? Calcium oxide. Remember that calcium carbonate, what's the common name for calcium carbonate? Limestone. Calcium oxide is what? Quicklime. Okay. If you look at now, there's also another one, which is the calcium hydroxide. The common name for calcium hydroxide is what? We know now that is what is slaked lime. But this one is what we call quicklime. So you don't have to forget this one. The common name for this one is what? Quicklime. Quicklime. So we're going to get this quicklime and do something. So I'll tell you why it is very important. Okay. So we're going to do something for quicklime. So we're going to get calcium oxide plus, now we're going to react with something very important, okay, which we call silicon. Okay, others they just call it silicate. Okay, so basically it is SiO, which is silicate like that. Okay, so we're going to get this silicate. So reason why we're getting this silicate, why are we getting this silicate? Because not among here. Okay, silicate, it is an impurity. You need to know about that. Okay, this is 2, sorry. Okay, so silicate is what? It is an impurity. Okay, remember that how we define ore. Ore is a mix of what? Minerals and the impurities. These impurities, all the ores that we are going to find in the water from the underground, are going to have the pure mineral and what? The impurity. Among the impurities, that's why we are going to find what? The silicate. Okay. Then if these two react, what do you think will be the product now? If the silicate and the calcium oxide react, what do you think is going to be the product? To be what? Calcium what? Silicate, like that. Okay, it is what? Calcium silicate. So we're going to have what? Calcium what? Silicate. Okay, so this is the product that we're going to have, the calcium silicate. Sometimes this calcium silicate is what we call what? Slag. Okay, it is called what? Slag. So this calcium silicate is called what? Slag. Okay, make sure that you understand about that. Now these are the important five chemical equations that we are going to be what? Assessed. Okay. Another one that I can add on here is this one, the last one. Okay, it's this one. In case you come across with this one, number 6, you're going to say again. We go back to this one. Okay. Now there's also another possibility for this first equation here. Okay. Carbon can react with oxygen, but if they say insufficient, so here for us to have carbon dioxide, the oxygen was what? Sufficient. But here, if they say carbon react with insufficient oxygen, basically the amount of oxygen that is there is not enough. If the amount of oxygen that is there is not enough, what do you think is going to be the product? Instead of producing carbon dioxide, we are producing what? Carbon monoxide. So basically, this the first step. We will go into the what? Second step. Okay, so we're going to produce carbon monoxide, and carbon monoxide was what? The reducing what? Agent, which was going to be used in the third equation here so that iron can be what? Extracted. Okay, so these are the important what? Chemical equations. So you need to write down this so that you can just go through them and fully understand them. Okay, now let's go back to this one. We're almost done. So let's go back to this this important blast furnace. Okay, now if you come here, there are some important structures that you need to identify. Okay, and the importance of those structures. If you come here, what do we call this? Okay, what do we call that blue line? As you can see, there are 2 layers that are important here. There is this layer in blue and there is this layer in what? Red. So what we call this topmost layer, we call it what? Slag. Okay, we call it slag, also called calcium what? Silicate. So this is slag. Remember that this slag is going to be on top of this what? Red substance. Okay, what do we call this red substance here? So this red substance is called what? What we call this red substance? We call it what? Molten iron. So we use molten iron, or what? Sometimes they use what we call pig iron. Okay, it can be either pig iron or molten iron, whatever the word that you are going to use is fine. Okay, molten iron or pig iron is the one that's going to be found on the bottom of what? Slag. Okay, now the important thing that you can ask is that what is the function of slag? So why are we forming slag and what's the importance of it? So basically slag is very, very important in what? Road construction. So you need to remember this. Okay, so if they ask you to say what is the importance of calcium silicate or the slag, it is important in what? Road construction. So very, very important substance. Okay, and the other importance in the blast furnace for slag is what? It will make sure that this iron that is being formed on the bottom is not combined with the other impurities. Okay, it's going to, no wonder it is on top here. The slag is on top of what? Molten iron, to protect iron from reacting with any other impurities above the what? The slag. So that's another important. Okay, it's protect. As you can see, it's on top of what? The pig iron here. It's going to protect the iron from reacting with what? In other what is substance here. Okay, very, very important. Okay, and the other property of slag is that it is what? As you can see, since it is what? It is on top of iron. Basically, it's simply showing that it is what? Not denser than what? Denser than molten iron. That's why it is on top. Okay. Another important thing. So as you can see, these in black, they are more like a brick. Okay, they are bricks. So these are what we call brick lining. Okay, these are what we call brick lining. Okay, so brick lining, as you can, this in black, all these are what we call brick lining, and they are very, very what? Thick. So they are going to ask you to say, why is this brick lining very thick in the blast furnace? Why? Because they help to what? They are going to insulate the what? The blast furnace. They will make sure that this blast furnace, this hot air gas that is entering into the what? Blast furnace doesn't escape. Because if it escape from the blast furnace, this temperature that we are having are up to 2000 degrees Celsius is not going to be there, because the hot gases that are entering into the what? Blast furnace, they are escaping. So to prevent the escaping of the hot gases there, what do you think? The brick line should be what? Thick. If the brick line is thick, they are going to insulate what is inside the what? Blast furnace, so that those chemical reactions that we're talking about here, or from talking about here, they can happen well. Okay. Generally, what we're saying is what? The reason why there is thick brick lining in there, it is because of what? To insulate the blast furnace from what? So that it prevents the escape of hot air gases. Make sure that you understand about that. So what the importance of hot air gases is to heat up the what? The blast furnace. As you can see, if they ask you to say what is the function of hot air gases is to what? Heat up the what? Blast furnace. The main function of this one is to what? Heat up the blast furnace. So let's say BF, blast furnace. As well as what? To speed up what they are going. So hot air gases, basically they are increasing the what? The temperature, and making sure that these chemical reactions are what? Happening at the faster rate. So they also, these hot air gases, apart from heating up the what? Blast furnace, they also speed up this chemical reaction that we are talking about. Okay. Now, the other important thing is that what is the purpose of these waste gases? Okay, what's the purpose of this? So this the purpose of what waste gases is to make sure that they, since we, as you can see from just from the word waste gases, we don't need them. Okay, so they need to come out of the blast furnace, so that what this homeostasis or this temperature in the what blast furnace is what it is maintained. Okay, otherwise the waste gases, if they were inside the what the blast furnace, basically they are going to interfere with this what chemical equation here. So in general, The importance of these waste gases is to what? Make sure that these chemical reactions that is happening in the what? Blast furnace, they are happening what? Correctly. They are trying to maintain the equilibrium of the what? Blast furnace. That's the reason why they are moving out like that. But basically, generally, we are not going to like throw these waste gases, they go into the atmosphere. No, we are going to reuse them, okay? So as you can see, carbon dioxide is a waste gas, okay? But we're going to use it so that we can make carbon monoxide, the gas that we need, okay? Okay, so that's where we end from under what? Blast furnace and the extraction of iron. Make sure that you like the video, comment, okay? Until next time.